All right, welcome. I'm Mr. Vosters, and in this video, I'm going to be showing you a few things that will help you to sort of finish off your 1.2.6 keychain charm project. So in this video, I will show you how to create a multi-view sketch. I will show you how I want you to dimension that multi-view sketch. I will show you how to calculate the volume of your object. I will show you how to export a PDF of a multi-view sketch, and I will show you how to export an STL file. Lastly, I will also show you how to scale an object, which is relevant for this project because remember, I have a volume requirement for you guys that is 1.2 cubic inches. If your object is larger than that, we will need to scale it down, so make it a little bit smaller. So I'll show you how to do that as well. So I have my object here. I made this little logo. And then first thing I'm going to do, I'm going to create a multi-view drawing for this. So I'll right click part 1 and I'll go to create drawing of part 1. From here, I'm just going to use the default 4 views and I'll click OK. OnShape will take a second to create that. There it is. Everything looks pretty good. I'm going to adjust this a little bit, just give myself some more room. So first thing I'll do, I'll add the dimensions. Now, we're not going to fully dimension this. Normally, you would need to dimension every feature and the size and location of every feature. So you'd need to dimension, this part and the size of the G and the width of this part. So I don't care about all that. For this project, I just want the overall width, height, and depth. So to do that, I'm just going to select my dimension tool. We'll start off with the width. So we're going to go from the left side to the right side. Right now it is 6.523. So that right away seems like it's a little too big. 6 inches is probably not going to fit in our 1.2 cubic inches, depending on how tall it is. So that's our depth up here. I did from the top to the bottom. That's 0.5 inches. And then our height is going to be from top down to the bottom. That is 3.6. So I'm pretty sure this is going to be too big for our volume. Last dimension I want to add is the distance from the edge of my G to the edge of the hole here. So this one's going to be tricky to dimension for mine because it's an ellipse. So this is not best practice, but I'm going to dimension to a hidden line. So I'm going to show the hidden lines up here. I should probably show my hidden lines over here just for good measure. All right, so then up here, I want to dimension from this edge over to the edge of the circle. So I'm going to dimension to a hidden line. I'm not recommending you do this normally, but it's going to be otherwise very difficult for me to get that dimension. So right now it says it's 0.3 inches. That needs to be at least 0.125. So 0.125 is what we need there. So we're meeting the requirement. There's more than enough material there for us to print this out. However, let's go check our volume before I move on, because I may need to scale this down. So if you're on the Parts Studio for your part, in the bottom right, there's a little scale symbol and it says display mass properties. We're going to click on that and it's going to say parts to measure. We're going to click on our part. If you have multiple parts over here, you want to click on all of the parts. I just have one part, so I'll click on that part and it will tell me the volume. Right now it is 6.424 cubic inches, way over our 1.2 cubic inch measurement. So let's close out of this and let's scale this down. So let's make it a lot smaller. So to scale something, you'll click transform up here. One other way, if you can't find this transform tool, you can just search transform and it should come up for you. The thing that we're going to transform is our part 1. We are going to scale it. So if you click the drop down here, you can select scale. our scale, let's scale it to 0.5. So if you select a number smaller than 1, it's going to shrink your part. If you select a number bigger than 1, it's going to increase the size of your part. So for scaling, you need to select a vertex. Our vertex, we're just going to select the origin. So you can see already it kind of shrinks it based around that origin. So if I selected like 2 and hit enter, it's going to make it way bigger, which is not what we want. We want to make it smaller. So I'm typing in 0.5, hit enter, and I can click the green check to see my smaller part. Let's go back and check the mass or the volume. So I'll click mass properties, click on my part again, and you can see our volume now is 0.803, which is within our requirements. So I can click the X to get out of that, and we can go back to our part drawing. So everything looks good. I do need to refresh the workspace since I did change the size of a few things. So I'll hit this little refresh up here. It should update everything automatically. That's better. So you can see we still do have the 1.25. We're a little bit over that requirement. All of our other dimensions updated. We may want to change the scale here just because it's looking really small. Let's switch to 1 to 2 for our scale. Maybe even 1 to 1. Let's see if 1 to 1 fits. Yeah, I think that'll be good. We can move this around so we can still read it. And we're almost done. We've got all our overall dimensions. We've got all our views. We need to add a note. So in the rubric, I said we needed to add a specific note. I'll jump over to show you that note here. It needs to say all of these things. So we'll say that all dimensions are in inches. We'll say what the material is, what the density is, and then some of the physical properties as well. So we'll start by just making this a little bigger so we can fit all of our text. So notes. And then first note was all dimensions are in inches. Second note said material equals PLA. And then we said the density equals 0.72 ounces per cubic inch. So inches to the third power. Our third line said physical properties. And then underneath that, we set our volume, which I remember from before was 0.083 inches cubed. And then after we do our volume, we can do our mass. Let's bump that over a little bit more. And our mass, we get by multiplying this density number here by the volume. So if I pull up my calculator, I can do 0.72 times 0.803, and our final mass is going to be let's round this to 2 decimal places, so 0.58 ounces. So we'll do 0.58, oops, I gotta be back in OnShape, 0.58 ounces. So you will have a different mass than I do, most likely because you will have a different volume than I do. If you're wondering what these are, so PLA is the plastic material that the 3D printer will use. It's short for polylactic acid. And then the density here, this is just the density of polylactic acid, or PLA. So we take that density, multiply it by our volume, that gives us our mass. Before you close out of this, let's add the color. So under physical properties would be a good place to say what color you want your 3D print to be, and I want mine to be green. So let's move this note up a little bit so it fits fully on our sheet. And I think we're done with our multi-view drawing. We can export that. So to export, remember, you'll right-click on the tab at the bottom of the screen, go to export, and make sure it's under PDF for the format. Under file name, I want you to change this to 1.2.6 multi-view drawing and then your name. So after you have this little bit here, put your name so I know whose it is, and then click export. And we're done with that portion. The other part of this that you need to do, you need to submit an STL file. So when the 3D printer is trying to print this out, it needs a certain type of file. And that's going to be this STL file. This is something that the 3D printer can interpret. So if we go back to our Part Studio, we can export a STL. So the way to do that is we right click over here under the parts menu and we right click and go to export. And then from here, we're going to make sure the format says STL, make sure the file name is 1.2.6, and then your name so that I know whose thing I'm 3D printing. And the rest of this should match mine. So make sure it says binary, units or inches, resolution fine, and then options download. So once that's all set, you can click export and you should see in your downloads a STL file. If you try to open that on your computer, it may not work. If you have the right software, it may open up automatically into that software. But otherwise, if you get an error when you try to open that STL file, don't be alarmed. All right. From here, let's close out of the calculator. From here, there's one other thing that you may or may not remember how to do, and that is how to get a link to your OnShape file. That's pretty easy. You just go up to share. You've likely done this before. And then you want to go to link sharing and then make sure that link sharing is turned on and then copy it to your clipboard. Once it's on your clipboard, you can paste it into Google Classroom. And then I will be able to access your file. So when I clicked on the STL file, it did bring up the MakerBot program, and that's what I will use to print it on our printers at the school here. All right, so that's it for this video. Thanks for watching. Hopefully it helped you with a number of things related to this project, and hopefully that'll go smoothly when you try to do it on your end. Thanks for watching. I will see you in the next one.